Hey everyone, in this video, I'm going to discuss about the continuation of this exceptional handling. So let's discuss what exactly is exceptional handling. In the previous video, we understood what are the reasons behind every error. So like what kind of different types of errors usually we get when we write a program. So now the question is like when you get an error, so how do you handle that, right? So that's where we have a concept called as exceptional handling. So exceptional handling is a way to manage your errors in a program without crashing your program. So it helps you in catching an error you can identify, and you can show user-friendly messages instead of red alerts, and you can keep the program running smoothly without stopping or without crashing. So that's an interesting thing about exceptional handling. You'll understand it more with examples. Then why we use an exceptional handling? Obviously to prevent a program crashes, provide user-friendly error messages so people can understand where it's going wrong and we can fix it easily. So handle unexpected situations dynamically. Let's say you write a very lengthy code and unexpectedly what if some errors occur in that particular program? So how do you handle that? So all those things we're gonna do it with the help of exceptional handling and maintain the control over the program flow. Even there is, even if something is wrong, but still my program has to run without any, difficulties. So usually in that case, we use a exceptional handling. Okay. So one important thing, how do you handle this exceptional handling? For that, we use these three things: try, accept, and finally. So try is basically used to write the code that might cause an error. So let's say, for example, it's like, whenever you feel like, okay, this part of code is going to give an error, okay, that code can be written within a try block, which helps you in detecting the cause for an error. Okay. So whatever code you feel like, okay, this code is going to give an error in the future. So you can just put that code within a try block. And then once it catches an error, it will run to an except. So this runs only when there is an error in a try block. Okay, so here you can give an instructions, specific or general guidelines in order to handle that error. So it's just like, okay, when error is caught, like what we have to do it, something like that. And then finally, we have like finally thing. This always runs whether there is an error or not, usually used for cleaning up like closed files or closing files or releasing resources. In that case, we use it irrespective of whether you have an error or not. So this code is going to run without any hassle or without any difficulty. So this is how we just make use of try, except, as well as a finally. And here is a syntax which you can understand clearly. So we start with a try, and just the code we're gonna write within the try, and except when this try block catches an error, it comes to an except where we suggest what can be handled, what can be done in order to handle an error, right? Then finally, so which always runs irrespective of whether your data has, I mean, whether your program has an error or not. This is like just like general thing. It doesn't really care about whether you have an error or not. Okay, so let me explain with a simple examples. So simple. Let's say for example, you have two numbers. Okay, I'll just call it like number is equal to integer of an input, and then number two is equal to integer of an input. Then what I'll do, I'll just write C is equal to or division is equal to C is equal to number one divided by number two. So this is my simple process. And now I just want to print C. Okay, say so it is expecting two numbers. If I give 10, if I give 5, yeah, the program works without any hassle, without giving right, without any difficulties or without doing without worrying. So what you can do, you can just handle this. Right. So next important thing that I want to discuss here is what if in case you give some different things in the sense, let's say for example, not every time you might input a correct values itself, right? What if in case you are going to input something like this? Let's say for example, you just given 100 and then you give denominator value as a 0. So it will catch an error. What kind of an error we got? So it's a zero division error. So There is a possibility that when denominator becomes a zero, it will catch up an error. Second important thing, it is expecting an integer, but what if I input a float? Again, you get value error. So there are two types of major error that you can expect knowingly or unknowingly. When user inputs different inputs other than integer, still your program fails. And also your program fails when denominator becomes a zero. So now what you have to do? So for that, you just need to use a try and except block. See, I'll show you like what to do. So just use a try block. Whatever code you feel like, that would throw an error. This is a code, right? This entire code would throw an error. So what I'll do, I'll just write that code within a try block. So make sure you follow the indentation. So it's number one, number two, and then this is division process, and then print C. Okay. And then finally, what I'll do, I'll just say except. Okay. Except I'll just print a statement. I'll just give a message when there is an error. Instead of giving an error like, okay, value error, zero division error, it has to give a very decent message like enter only integers or and okay, enter only integers and numerator two, number two, sorry, number two cannot be zero. Okay, let me run. So if I give 100 and if I enter a 50, well, it works perfectly fine, no error. You can clearly see those, right? So in the next case, just see here. So I'll make a mistake like, I'll enter 5.6. So it is giving me a message. Instead of showing like value error, it is giving a decent message. So whenever this code catches an error, what this try block will do, it will jump directly to this except. Try catches an error, then it will jump to an except block. And then in this, it is printing a message related to except. That is, it is saying enter only integers and also numerator cannot be zero. So you understood what is the mistake. You have to correct it next time. Okay, so let's say for example, what if you enter denominator as a zero? Again, you don't get an error like zero division error. Rather, it just gives a message like, okay, enter only integers and number cannot be zero. So that's an interesting thing about, try and accept. There is one more finally, this is irrespective of your error, whether you have an error or not. This is like, just like general thing. It just runs without any difficulty. I'll just say like have a nice day. Whether it catches an error or not, its job is just to print. It doesn't care about a try or accept. This is like normal printing. Okay, normal printing, it is not dependent on anything. That is a finally block. I hope this is clear. Right. Now you might have a question, one more question. Like, what if I want to specifically raise a error? Let's say this is like giving general errors, right? Like let's say for example, when you enter something wrong, it says like single message we are giving. Let's say I want to give messages with respect to every error that I'm catching. So what I'll do, I'll just say except, so value error. So whenever your code catches an error, if it's a value error, in what case you get a value error? So in that case, I'll say just, enter only integers. Enter only integers. Okay, this is an instruction. Next one. So what if in case if somebody enters denominator as a zero, then I'll just say like except. So it's going to be zero division error. Yes. So zero division error, and then it has to print. I'll see specific message like number two. It cannot be zero. See, this is interesting. If I run 100, if I give 100, if I give 20, it works perfectly fine. So no error. Everything is perfect, right? Okay. Let me copy paste the same thing. Let me input a float. So it is expecting integer. If I input a float, obviously it catches a value error and it says a message like enter only integers. See, for specific error, specific message, you can write it. Right? So it's easy to catch like what exactly is the mistake. Next one. What if I enter 100 and what if I input denominator as a zero? It just gave me message like, number two cannot be zero, right? That's an interesting thing about, except. So according to errors, you can identify what exactly we can give a message, okay? So one more important thing, what if in case you want to identify like what type of an error it is? Okay. So you want to catch what kind of an error it is. So let's just use exception as E, and then I'll ask it to print E. So what it will just give you the exception. Let's say, for example, if I say 3.4, uh, I think it should be capital E, probably. Yes. Okay, so let me run it again. Sorry. So now what I'll do, I'll just enter, we'll do some mistake and let's just see like what is going to happen with this particular program. Okay, so I'll just give 3.4. We know what type of an error we get. We need to get value error, right? See, it's giving invalid return for integer. That means if you want to know the type of an error as well, you can actually call type of E. Okay, so not just type of E, I guess it would be, yeah, type of E dot its name, you have to capture it. So just call type of E dot double underscore name double underscore name. This gives you type of an error as well. See, if I enter a float, it just gives a message like, okay, it's a value error. Can you see? It's a value error. So we're expecting integer, but you have given a float. Interesting, right? So same way. Let's say you want to catch a zero division error. Simple again. I'll just input 100 and give a zero. So it will catch what type of an error it is. See, it is saying zero division error, that is division by zero. Simple, right? Great. Okay, now next important thing, you can see here two questions wherein you have some numbers as well as a string. Now the question is, you have to write a program in such a way that you have to find some of these numbers, only the numbers using try and except, and you have to just ignore the string. So how do you do it? So very simple. So you all know how to find sum of numbers. So let me just initialize initial sum is equal to 0. Okay, initial sum is equal to 0. And then I'll just make use of a for loop. So for x and a, we'll loop through all the elements in a list. And then I'm just using a try block. Because I'm pretty much sure, like when I try to sum, obviously I might end up with an error, right? So I'm just using sum is equal to sum plus x. I'm just using sum is equal to sum plus x. Okay. And then except. See, whenever it's a number, it will perform the sum. Okay, whenever it's a number, it will perform a sum. Whenever it finds a string, whenever it catches an error, I'm just saying pass. Pass means just ignore it. Okay, finally, I'm going to print sum. Just see the magic. It's giving me 2700 by adding all the numbers and it is just ignoring all the string elements. Interesting, right? So this is how you can use an exceptional handling to ignore things that is which are not relevant. You can just ignore it using try and accept, and you can continue the flow of what? Your program. Okay.